Well, hi, good morning. Thanks so much for joining me in my shop here. I'm going to be doing some odd experimenting on this radio today, but first I want to tell you a little bit about what I did last night. I just couldn't stay out of my shop. I came in here last night, thought I'd spend some time doing lots of mundane things. So, one of them was, hey, I put light bulbs in the radio. So now it has 5 operating light bulbs. 2 were burned out, 1 was loose. The light bulbs are definitely in the wrong order, all except for the broadcast band. How that happened, we can only guess. I examined as carefully as possible this bundle of colored wires. These wires head up to the light bulbs, and this switches the light bulbs. Very clear indications in some of the information I have about what color wire goes where. What's not clear anymore is what color these wires are. So, as much as I could, I determined that they were wired properly at the switch. I didn't bother with the lights. That's where the error must be. It must be up where the lights are. So, that does raise a general question. If somebody could make a mistake like that, and it could survive whatever process the factory had for checking these radios on the way out the door, then what else could have been done wrong in this radio that was not discovered at the factory and has persisted all the way to here? That's an interesting question. Just because the wiring's done wrong on the lights doesn't mean anything else is wrong. It just raises a question about that. In this radio are a number of unusual looking capacitors. Here's one of them. Previously, months ago, when I had this radio on my bench, I cut this one away and measured it. It seemed to be exactly correct, so I just reattached it. I cut this one out last night. This particular capacitor conveys all the oscillator signals to the oscillator grid, the oscillator tube grid. So I thought, well, it's working on the lower bands, not working on the higher bands. Maybe this guy doesn't have its capacitance anymore. This one is supposed to be exactly 110 picofarads. I have a 110 picofarad capacitor. There it is in its place now. Took this out. First I cut one lead and measured it. Instead of getting 110, I got 119, I think it was. With it out, like this, and testing it using that digital tester I have, I got 107. Wow, that's pretty close to 110, isn't it? I also put this on my high voltage tester to see if it was leaky. 0 leak. This capacitor passed every test. But here it is in my hand, and that one went in. Operation of the radio did not change from that. They also changed out these 2 resistors. Did I do that on video yesterday? Maybe I did. So these resistors had gone high, and so I put decent replacements in here. Very, very close to. They're supposed to be 33,000 ohms according to the schematic. And these are measuring at 31,000 ohms. So I think that's got to be close enough. Again, made no difference in the operation of the radio. So I also spent a great deal of time trying to examine the switch, looking for something broken on the switch, trying to find out something that's out of order or connected wrong or anything like that. No, couldn't find a single thing. Yet the radio is silent on the 2 higher bands. The local oscillator does not kick in. So, with a little bit of frustration last night, I set it to the band it's on now. This is a 9 megahertz band. So it has 4 shortwave bands. The 2 lower ones working, the 2 upper ones not working, and of course AM is working down here. I discovered, and it was no big deal, I hooked the antenna up and just tuned the radio. Wow, it was picking up lots of stuff really well. Compared it to my SDR, and I would rather listen to this radio than my SDR in my shop here. Of course, it's got this great big whopping speaker, but nevertheless. The other thing I noticed is that the bands that this radio covers, these are band spread bands. They don't actually cover the modern shortwave frequencies properly. For instance, the band we're on right now runs from 9400 to 9700, but the shortwave band is actually much longer up here. I guess it got extended somewhere in history when they just didn't have enough room for all the fantastic shortwave broadcasts. And if somebody tells you there's nothing on shortwave to listen to, they're not telling you the truth. There's lots of stuff on shortwave to listen to. So, in a nutshell, here's my idea. I'm wondering if these are the two coils that are used for the two dead bands. I wonder if there's any resonance at all going on in here. In other words, even though the oscillator doesn't break into oscillation, the coil and capacitor combinations that exist, the tuning capacitor, trimmer, all that kind of stuff, is all that okay? Are these things ready to ring at the proper frequency that they're intended to ring at, and for some reason they're not? Or is there something wrong with these coils in some way? Okay, I checked their continuity, all that kind of stuff. It's all long gone by. Something very curious must be going on, and I'm having a hard time finding it. So in a case like this, where I really don't know what to do next, because I think I've done just about everything I can do, I just dream up something to try. So what I want to try is making these coils ring. And the way I want to do it is I want to bring a non-resonant coil, something like this, with a signal in it at the resonant tuned frequency of these coils, as best I can tell by looking at the front dial and tuning the radio, and bring up a source at that frequency and see if these coils pick it up like a radio would, like the front end of a radio. Not quite like an oscillator. A little more like a regenerative radio that does its thing. So I thought about, well, how can I do this? I mean, this part's easy. I can energize this coil from my signal generator and control the frequency and bring it up. That's no problem. The problem is trying to pick it up. So what I'm thinking is, with the set turned off, and I better turn it off right now before I forget, I'll take my SDR radio, I'll connect the antenna to a place in the oscillatory circuit, somewhere where it won't throw the circuit off. I'm not exactly sure where that would be. Probably on the plate of the oscillator tube. And bring up my coil. And now I'm just thinking, you know what, without the tube in place, yeah, no, it should still work. Even with the tube turned off, it should still work. The coil and capacitor should still be connected together. They should be doing their thing right now if I switch to that band. So you heard the radio playing. The radio's roughly tuned to 9550 right now. Not a lot to hear on that band at this time of day. I was surprised there was anything, in fact. Some strong signals outside the range of this radio. That's when I discovered, hey, this guy doesn't quite cover the entire band, and there are some outlier shortwave stations that broadcast off the ends of the standard shortwave broadcast band. So it'd be out of the range of this radio, unfortunately. Well, I'm going to start with a known to be working band. That's the one I'm on right now. I'm going to tune the radio. I'm going to turn the radio on. I'm going to tune it. I'm going to find out what frequency it's tuned to by using my signal generator here. And then without doing anything, I'm going to turn the set off, present that frequency to the coil, and see if I can see something happening on the SDR. That's my plan. So I'm going to set stuff up to try to make that plan work. And then I didn't finish it. Then once I see that this method can work, I can detect a resonant arrangement in the radio this way, I will then switch to the dead bands and attempt the same thing again, and see if the dead bands behave the same way as the live bands. Where this will lead, I don't know. But it should be fun. It should be fun trying this. Yeah, I said to myself this morning, I got to have some fun with this radio, because last night was not fun what I was doing in here. It was quite brain teasing. I don't like working in the evening either. Okay, let me set all this stuff up. Get going. Okay, step one is to know for sure what frequency the radio is tuned to. So I simply have my signal generator on the antenna here. It's up around 5. Let me look. 9.5 or so. Around 9.5. Well, that's right on the band change here. Well, I can get to it. Thing. Yeah. Well, it shows you that the radio's precisely tuned to 955. Wow. That's a winner. Okay, so we're gonna set this on right on here. Turn off the radio. Take this off here. So now I'm making a mistake. Okay, that's okay though. I can correct my mistake. So, oh, this might not work out. That's what the radio's tuned to, but that's not what the local oscillator is operating at. The local oscillator is going to be 455 above or 455 below. Well, we'll have to hunt around for both, I guess. I think it's below in this radio. Okay, that's a little bit of a complication I wasn't counting on. Now, I'm going to hook up my SDR. I'm going to still use a capacitor to protect it. As soon as I can find them. Here they are. What are they doing there? I want to go on the plate of the oscillator too. I think it's probably the... What if I look on the circuit diagram and see where the radio itself takes the oscillator signal out? I already know that. It's on the... It's right here. It's right here. It's right this capacitor that conveys all the oscillator signals, no matter what band you're on, to the grid. There's the grid wire right here, going up to the grid cap. So why don't we go on here? Go on there. This is pretty low risk to my SDR radio. I have an RTL SDR, cheap guy. If I had there are much better SDR radios out there that you pay some hundreds of dollars for. I would never risk them this way. I don't think it's much of a risk. Okay, so all I got to do is watch the SDR screen now. Tune this guy past the local oscillator frequency, above or below. I tried both, and see if we don't see a response or something on the SDR. First, I'm going to go drink some coffee though. Okay, so the SDR is already tuned into the area there. There's one peak sitting there. I wonder what that is. Could that be this? So I don't see anything happening at all. Have I got this set up right? I think so. So that's at 95.50, and you'd expect to see something at 95.50. It's just to the left of that peak that's on there right now. If I can get any of this in there. Well, I see something showing up, but it's on way too far left. Oh, there is something showing up also. Band. Now what I'm hoping for is a strong signal when I hit the resonance. It's not what I'm doing right now. So what is that? Let me hang this here. Turn this up. Clearly see it. That's this frequency right here. 9700. Where's that coming from? So if we're tuned to 9550, the local oscillator below would be 9100. I don't see how 97 fits into the picture at all. I'm going to switch bands briefly, just back and forth. Well, there's something going on. Okay, 9550. Don't forget that number. I'm going to go down to 9100 and see if something doesn't come flying up. 9100 is way down here. Not that that matters, but we really want. Yeah, this is where it would resonate. Around here somewhere. I'll put the red line there. That's what we're looking for. Okay, tuning down and watching everything here. I'm going down in frequency. It's going up. Coming into the resonant area. There is something there. Right there. Well, I got that at 9100, and on the screen I'm picking up 9100. How do I know it's not just the signal out of the signal generator? I was hoping for some wild burst. What have I done wrong here? You know what I've done wrong? I put the yeah, I didn't want this near the coil. Okay, so we're on the 31 meter band. That's this coil here. I'll put this near that coil. That's really what I need to do. Whoa. Okay, now the deal is I tune the radio and watch this go away. Now this is kind of what I was thinking would happen. It's assuming the local oscillator is below. Okay, I'm going to tune the radio. I want to be able to tune it back. So it's on 9555. Okay, tuning now. What I would think is the resonance of the coil is changing because I'm tuning the radio, and that strong signal should go down. It's not at all. Okay, so this whole idea might stink. It might stink for reasons I don't know yet. Okay, so maybe the local oscillator is actually above. So 9500 plus 455. Oh, it's pretty much 10. Gotta go up on the next band. Come way down. Let's watch the SDR. Whoa. Strange stuff. There you can see the actual sort of raw signal over on the right there. It's at 10.5. Yeah. Now let's just think a minute. What am I doing here? I've got the yeah, we're looking at a range of frequencies on the SDR. So So I guess what I'm thinking is when I hit the resonant point, the signal in the SDR should zoom way up. Yeah, I don't see any zooming. You see, the SDR needs time to process the signals that I'm feeding it. The SDR is about a second, maybe not quite a second behind in time. Okay, so this didn't really show anything at all. Well, it could be the pickup point. Maybe sticking this capacitor in here has disturbed something badly. Can't imagine that. Okay, there's really no risk in this. I'm going to just hook the SDR directly here. Probably won't make any difference at all. I think what I really need to do is use a sweep generator here. A sweep through a range of frequencies and see what comes bouncing out of the radio. The single frequency thing, little tough. Maybe with a sweep. Okay, gonna take me a couple minutes to get that all cooked up in here. Okay, so the sweep generator I'm using is this guy up here. And you can see the sweep on the SDR. This signal generator is doing nothing now. I just left it on. So I've got the SDR antenna just clipped to the insulation on the feed loop coming from the sweep generator just to get it on the SDR so I can see it. Just sweeping right through the shortwave band there. Can expand the sweep, make it wider. The SDR itself is trying to handle this odd signal it's receiving. That's where some of the bouncing is coming from. Okay, I'm going to move the frequency upwards a little bit. It's an interesting effect. Sweeps seem to get a lot wider. Why does it seem stuck on one frequency? Like it seems centered on that thing in the center there. Something funny going on here. Well, that's good. I'm looking for funny stuff. I'm not looking for something like that. Well, that was just a little hard to explain. I'm making adjustments on the sweep generator. The sweep width. How did it go inside out like that? That's got me. Okay, let's just do it like this. You assume what we're seeing on the SDR is the real thing. This could be because I'm so close to the end of the band here. It's behaving a little bit odd. So now we're sweeping all the way up to and beyond 10. So the sweep should be going through, the sweep frequency should be passing through the resonant frequency of the coil I'm interested in, which is the 31 meter band coil. Okay, so we're going to take this off. I should move this right over like that. Take this off here, put it back on our supposed detection point. I'm going to move this coil around a bit here and just really get it on that. Now, of course, putting this near this coil changes the dynamics of the coil a little bit. Is there anything there at all? Well, there's two little peaks there. Okay, the rocking and the moving up and down, that's the SDR signal level control doing its thing. I'm going to tune the radio and just see if I'm moving the resonance point, and that's what one of those points are. And I did not see anything happen. Could be something very subtle. At the end of the band here. There we are, that's the end. Well, this looks like a complete failure. I completely reverse this. Use a coil for a pickup. Inject the signal right into here. Why not? Why not? I don't know. Can't do any damage to anything. Okay, so no longer a direct connection. Now we'll just hang this from there. And we'll connect this guy. One on ground. This should show up pretty good. Didn't make any difference, really. I think I'd be energizing this coil somehow with the sweep. Let's go past the capacitor more directly. Okay, maybe it's there. And I gotta tune the radio to move it around, whatever it might be. Is there anything moving? Anything? Anybody? Anywhere? So I'm testing the test is what I'm doing, and it turns out this idea is not happening. Not happening. Am I making a mistake in where I'm injecting the signal? Am I injecting lots of signal? Yep. Everything I'm giving it, everything it's got. Let me change bands. That's the one we were working on. Well, this is the broadcast band, 6 megahertz band, 9 megahertz band. And then the two that don't do anything. Well, that's kind of interesting in itself. Don't have any clue what it means, but let's tune the radio and just see what happens. Shouldn't expect anything to happen based on my brain. Okay, back up to the band in question. There's just something wrong with my approach here. Yeah, obviously there is. Coffee is what is needed now. Okay. Oops. What's all that? Ooh, wait, what was he doing there? What happened? Okay. Let's try a different band. I'm kind of stuck for things to try, so if we go back, broadcast 6 megahertz band, we'll just try the same thing on the 6 megahertz band. Now I gotta make my sweeper go down to 6 megahertz. can do that if I flip to A band, and I have the feeling my sweeper doesn't work on this band. This is the one band it didn't work on. Yeah! Nothing showing up there at all. Yeah. That's right. I thought, well, I won't need that band anyway. Well, look at that. Okay, so we can't get down to 6 megahertz. The bottom of my sweeper is around 4 megahertz anyway, if it were working on this band. Let me put it on the band we just had it on. The bottom is 10. Does it by any chance leak all the way down? Ooh, something went by there. Something moving around. If I turn up the sweep width maximum. No. Okay. Wow, this has been. I really thought I would get somewhere with this, but not yet. Let's go back. Make sure I go back to the band in question. What I'm hoping for, I really haven't said what I'm hoping for, is some kind of peak is going to show up on the SDR that will move when I tune. And could it be it's there, but it's covered by noise? That doesn't quite make sense. Is what I'm seeing on the SDR actually reflective of what is coming out of this coil? What if I move this elsewhere? Well, that's pretty convincing. It's because I have it close to this wire, and it's really nothing to do with the coil. I'm failing to couple tightly with the coil. The tighter I couple, the more I throw it off anyway, but let's do that, because what else to do? You stick it in like this. There's a rod in the way there. There. Can't imagine this. Let's swing this way. What happened on the SDR? So there's a little trick I've learned to play with the SDR here. And it's not worth showing you it right now. Let's turn the sweep width way back down. Way back down in this range. I just like to see the edge. It really kind of indicates where things are. So the trick is, if you look on the SDR lower left, you'll see me move something called the S delay. Watch what happens on the SDR. Very relaxing. So what's happening is the signal is not decaying off the screen. It's just being added on more and more and more. Interesting enough, ultimately you get kind of a nice smooth thing up there. I would expect if there was some kind of a peak, we would see it. Well, I certainly don't see it. And you can reset it very interestingly, very easily, just by pushing the S delay up for a moment and back down again. So you can kind of rewrite it if you like. In some other applications, this is extremely helpful. Otherwise, it's a bopping up and down. You have to use your own brain power to understand that. So, for sure, the SDR is picking up the sweep. We're looking at it. A sweep is going through the range of the local oscillator, I do believe. At that point, I would think this coil would ring out. And when it rang out, the SDR would show it. That's my theory. Doesn't appear to be worth squat. Can't try another coil because the sweeper won't make it. I could try this on the broadcast coil. I have another sweep signal generator, but it will only go up to it goes up to 5 million. 5 megahertz. Well, we'll try the same thing on the broadcast coil. The sweep generator I'm using now can't get down to it. I'll switch to the other sweep generator and we'll try it on the broadcast coil and see what kind of nonsense we can come up with there. Because I just very much think this should work. So, you know, that's what drives people forward, stupidly thinking something's going to work. Okay, here we go. We're down on the broadcast band now. So we're going way down here. There's all kinds of weird stuff going on. This is all noises and interference that you're seeing. Now, the SDR is this coil, which I've got tucked up near the broadcast coil right here. Oh my gosh, how you're going to find anything in there? By tuning the radio and seeing stuff move, that's how. This is the output from the sweep generator. First we want to see if we can see it at all. This is a low level guy. He's going at max. So what if I just hold it up like that? Anything happening? This is fairly weak. We could just touch it there. Let me slow the sweep rate down once per second. So we should see something moving along. There it is. Look at how weak it is compared to all those noise signals. Holy smokes. My pickup coil's picking up. Okay, well it just means if we hit the resonant point, maybe it'll really come out. So this guy's still going here, the other sweep generator, but its frequency is way out in the boonies now. I'll just set them aside. I'll start by trying to feed this in the same way, right into what I think is the right spot. I wasn't looking at the screen there. Yeah. This doesn't look good. Okay, we're still sweeping at once per second. See nothing. Tune the radio a little bit. Wow. Oh, that's interesting. I don't have an antenna on here. I think that has nothing to do with the sweep. Exactly what we're found something. That's, well, you know what that could be? That could easily be the resonance of that of the local oscillator coil, and it's just reacting to noise. Okay, I'm tuning the radio all the way to the lowest frequency. It'll do. For some reason, I think that's a good idea. Yeah, the effect seemed to just kind of wear out down there. Let's go back up to where we can kind of spot where the peak might be. So I would make it out to be right around 14, what is that? I can't read it. 14. I'll put it right on 14. I'll put it 1455. That's a smart idea. Okay, so I'd say that's about 1455. That means the radio's tuned to 1,000,000 hertz. Tuned to 1,000,000. It's set up to receive a station at 1,000,000 hertz. Is it? Okay, I'm going to look at the, come with me over here. Let's take a look. What are you tuned to? We're looking at this middle band. That's 900, and that's 1,000,000 up here. So it's very close to 1,000,000. So I think that's what we're seeing. I think we're seeing the resonance. We're seeing it not because I'm sweeping it, but because there's enough noise and just junk there that we can see the effect of it. So that kind of worked. Didn't even need the sweep. Don't even need the sweep. Just need a lot of noise. Just need a lot of noise. Really? That really worked. If I pull this way over here. Just tune the radio, of course, you can't see anything. It's definitely coming from that. Now, what if I put it back on here? Now, can we still see some resonance thing happening? Tune away here. Let's say no. Going past the 1,000,000 point. I can't make anything useful out of that, I don't think. This isn't the best pickup point. Maybe that's what that's proving. My theory on where to pick the signal up, not correct. What if this coil is just terrible at picking the signal up? And that's not much of a coil, is it? I've got ones that look fancier. Here's one. Just the coil in this little end here. Don't knock fancy looking stuff. Fancy. Okay, broadcast coil. Tuning. Hand effects and everything going on here. Well, doesn't seem to be doing it now. Get back down around the 1,000,000 area. Okay, back to, so this didn't work. I have other coils handy. How about this great big honker? You don't want the pickup coil to have a resonance within the range of what we're trying to do here. Let's kind of pick it all up. Nothing. Back to my El Cheapo clip lead coil. Putting it near the broadcast. Nothing. Stick it right up against it here. This is how I think I had success before. There it is. Right up against it. Okay, so I come off. Oh! I didn't have the radio on the broadcast band. Oh! Hey, that's how discoveries are made. What are you discovering? You're discovering how dumb you are. That's what you're discovering. Okay, broadcast band. Repeating. Well, it could be. Maybe. No, it couldn't. I was going to say maybe the coil's always doing its thing. Doesn't matter what band you're on. That doesn't make any sense. Okay, once again, just checking. I'm on the broadcast band. So, a little bit of a guessing game, but I would say try and tune it gain to 14. So I think that's it. I think that's 1450, which means the radio should be tuned to 1,000,000, and yeah, it's in the same spot again, very close to 1,000,000 on the dial. That's well, I don't know what that means. If I change bands, does it not just top, 2 dead ones, good band, broadcast. So we can see a little change when you get to the broadcast band. Does that mean I did the sweep test with it on the wrong band? I don't know. Let's put this back on. We are now sweeping with my oh so weak signal. What if I were to ground this lead here? Well, it doesn't help much, does it? Well, I don't know. No, it's just more junk screaming at it here. If I wrap the whole radio in tin foil. Well, what happened here? So I'm on broadcast band, I'm near the broadcast coil. Well, what happened to it? Is it because I did that? Okay, I can kind of see something happening there. Well, yeah. Well, up at 9 megahertz, there are not a lot of radio noises anymore. They're still around, but they're nothing like down here in the broadcast band. You can see all those teeth. Okay, we're going up 1 band. The coil is right beside the... My pickup coil is right beside the oscillator coil for this band. Well, I should go up and look, not here, but up at 6 megahertz. I guess there could be things going on in a radio at frequencies far removed from where the radio is tuned, and they're of no consequence, and perhaps even never known about in the early days of building radios. It would take quite a bit of effort way back when to discover that, you know, when you flip the radio to broadcast band, that there's a superfluous signal in it somewhere, resonating somewhere, which is no consequence for the radio itself. Maybe. Okay, so the radio now is tuned to 6100. That would be down around here, and if you add 455, you get 64, something around in here. I'm going to expand this a little bit. Okay, just based on watching what happens to the signals that are there, it's just not gonna, this is not gonna work. I just really. Okay, let's bring in the sweep. My old sweep generator here. I'll try feeding the signal in through the grid connection. In through the outdoor, basically, in through the out. Just checking a few. Frequency should be way down here. Oh, there's something. More sweep width. You can see the edge of the sweep going by, coming back. So I'm sweeping through. sweeping through what I believe to be the resonance of the coil. Tune the radio. I can't believe I'm going to see something here. Nothing. Clearly, I'm only halfway through my coffee. That's got to be the problem. Okay, small aside, you see the meter on my signal generator is going off scale here. Seems when I operate my big old signal generator these days, over time, maybe after about an hour or so, this meter just starts drifting up and up and up, eventually gets pinned solid. And if I turn it off, it doesn't come down. Yeah, Peanut. What's the story there? Okay, oh, there it goes finally. So, something going wrong with that machine too. Peanut, Gesundheit. So, I was just thinking a bit about what's happening here. And so, on the broadcast band, I was able to kind of see maybe the resonance of the local oscillator coil based on all the noise that was in it. All the noise that was in it. All that noise is in that coil? Does it matter if the radio is switched on or off? All that noise is present in the coil. So there's lots of noises in my shop, of course. I got a computer running, a couple screens, all that stuff. And all that stuff is getting into this coil. Which would mean if you turn the radio on, all that noise is still in this coil. Wow, that's an interesting question in itself. So when you're hearing all the crackling and noise and stuff coming out of the speaker, I think it would be true to say some of that is noise at the antenna that's at the IF frequency and is able to go through the radio unless there's a trap. Some radios have traps in them to trap out that kind of noise. It also traps the local oscillator on the way out to the antenna. So you don't have a local oscillator, whining away in your backyard, showing up on everybody else's big old radio. But surely to goodness, if there's that kind of noise just in these coils. Now this radio probably has a metal base. I'm not sure. I am sure I have it. I think I have the metal base somewhere. I don't know where. I'm not sure. I mean, you can see they put metal panels in here to try to shield the coils from each other. And of course this radio was made a little bit before everybody had a computer in their pocket. That's an interesting thing in itself. And whether that observation is really valid or not, I'm not sure. So if we just have this coil, just stick it out here on my bench. All by its lonesome here. And let's see if I can flip to the SDR now. So this might be indicative of just the kind of noise that's I'm holding the coil in my hand and squeezing it, and you can see some kind of variation there. What that single signal is at 6, just above 6, I don't know. It's not coming from the radio or anything. Signal generators are off in the room. Sweep's still on. That can't be doing that though. No. Oh. Yeah, you can see something going by there. I'm just changing the sweep frequency. Let me turn the output down. There. Okay, so that can't be in the picture. So that's just general noise here in my shop. Let's go down and just look at what happens here. That's what that sounds like. Okay, just keep going down another megahertz. Another megahertz. Down into the AM band. Look at all that stuff showing up. So, in a sense, my shop is full of test signals, if I think of them that way, down at the low end of the band, down at the AM side of the band. So then I take the coil and move it around a little bit. This is tricky to do because there's a 1 second delay. Oh, what was that? I'm barely moving it here. What was that? I don't know. Yeah, I can't really tell you what I'm looking at. Okay, I'm going to stick it in the radio. Back where I had it, where it's trying to pick up the broadcast coil. The noise level went up. Is that just because I stuck it into a thing, you know, a big metal thing? It is an antenna in itself. What other big metal things have I got kicking around here? I have a tooth tester. That's a big metal thing. I can stick it in there. Okay, you can't really see what I'm doing. I'm pulling it out of the radio. So now it's airborne. It went up. Oh. Why is it jumping around like that? It's just the way I'm handling it. Okay, and now I'm going to hold it above the other big chunk of metal. Here, just a second. Quite a tangle up on the cords. Okay, this might really shield it. Okay, I'm plunging it down inside a metal box, and you got more signal. Pull it out. It drops a little bit. Okay, sticking it back in the radio. You're probably wondering, what in heaven's name is this guy doing? I don't know. Poking around. Trying to make a breakthrough. And I wonder what all those signals really are. I turn off my computer to find out, but I'm afraid that would stop the video. It's almost certainly, well, I can wave it around my computer screen, for instance. Okay, so this is around one of the computer screens. Ooh, here's a spot. I'm pretty sure those things fire out noise and big time. They can fire out big time noise. Okay, now we're gonna go up near my big screen TV. Oh, wow. Look at that. I'm just waving it around. I'm rubbing it over the screen of the TV. I can turn that TV off. Okay, I'll do that. So I'm just holding it a couple feet away, and it's off. Oh, for crying out loud, I'm looking at it. It was a false test there. Let me hang this here. Okay, I gotta turn it back on now. There it comes. Well, it's certainly not causing the ones we see right now. Where those are coming from, I don't know. You know, I've done a lot of this hunting around kind of thing, and yeah, who knows? Who knows where it's coming from? Well, we're really just fishing around in the dark now. Gee, I really wanted something to work here. Okay, I got a whole different approach. Well, how about a whole different approach? Okay, next crazy idea. What I'm going to try to do is operate it on one of the bands that doesn't work. I've picked the lower frequency band and I've tuned the radio to the bottom of the band. That's the least demanding in terms of how high the frequency is in the local oscillator. So my best chance of this working, yeah, don't put your money on the table for this one. That's for sure. I'm going to use this signal generator. Let's turn it on. Hope it doesn't right over. I'm going to try to feed in the correct local oscillator frequency into this yellow coil, which is right near the local oscillator coil. Oh, see, it's gone right over there. Don't like that. It's pinning that meter very, very hard. Well, that's interesting. So I've turned off the modulation. I don't think we need any modulation anyway. So it's kind of the modulation side of things. Where's the power? Oh boy, there was next to no energy coming out of it before. Okay. That's the way it goes in my shop. Well, we got lots of power coming out of it now. So I'm going to try to dial this up to the proper frequency of the local oscillator and try to help this guy to oscillate. That's my plan anyway. The radio's tuned to 11700. To avoid embarrassment, I've added and subtracted numbers off camera. So the local oscillator, if it's below, it's really tuned to 11250. If it's above, it's 12150. Something like that. So we want this up at 11250 to start. 11250, roughly. Signal level's low on that guy right now. So I'm going to turn on the radio. Start seeing what happens. Okay, so there's nothing. So this is the SDR antenna connection. It's not actually clipped directly to anything. It's clipped to the ground here, but this other clip is clipped to some insulation right near the area where the output signal is derived or transmitted to the first. What is it transmitted to? Transmitted to the grid of the oscillator too. Okay. Here we go. Turn on the radio, see what we hear. Maybe it's working. The band that's lit up is a 9 megahertz band, but I know I'm on the 11 megahertz band, in fact. Okay, just give it another moment. I think that's a tube, internal partial discharges, I guess you could call them. Tuning around a little bit. No, it's not. It's not working. Okay, so now we're gonna blast in a signal into this cable here. Last time, didn't I find it was just this tube? Yeah, I thought I resolved that. Something more going wrong there. Okay, here we go. Where are we going? And I got the yeah. What's that signal I see at 11.8 something or other? Probably nothing to do with the radio. Let's just cut the power briefly. No, nothing to do with the radio. Okay, so we're going to tune this. That's okay, I can step in front of the camera here. We'll watch the SDR. And what are we looking for on the SDR? What are we looking for? We're looking for suddenly there to be a powerful local oscillator signal matching what's on here. That's kind of like yeah, I don't know about this. Okay, up on the power. Okay, so you can see the signal generator signal now. little bit of static's coming out of the audio side of things. Okay, ignoring all that. Ignoring reality as much as possible. Dial up to well, I'm almost there, 250. Okay, watching now. Oh, 11,700. So something's showing up at 11,700. And that's just about exactly where the radio's tuned. So, what's that mean? 11,700 from down in here? What is that telling me? I guess keep fooling around here. So I think what's happening is I'm kind of replacing the local oscillator with my signal generator. So in effect I'm tuning the radio. Let me turn it up. Hope nothing loud happens here. And when I cross, I don't know. Stop thinking. Just keep doing. Now, even though you see the signal going up and down on the SDR, that's just the SDR. The signal is actually continuous, smooth, a wonderful thing. Okay, so assumption could be it's not, the local oscillator is not below, it's above. If it's above, it's up at 1250. 1250. So I'm just going to move the screen over here to get 1250 onto it. Okay, we'll go up to 1250. Listening carefully to the radio. Okay, so interestingly enough, nothing showed up at 11,700 at all. Let's just go back down to, what was that number? 11,250. It's off the screen now. Not there yet. I'm staring at 11,700 on the SDR. Whoa. Did I see something there? So, okay, 11,250 is right around here. Saw something last time. What happened to it? Error. Everything's still where it was. How can I increase the coupling here? Stick it right in like this. I can't seem to reproduce what I did a moment ago. Why, if I'm feeding in 11,250 before, why did I see it at 11,700? Because I'm simply replacing the local oscillator with external oscillator. that's causing any signals that are available at 11700 to come through the radio. Hey, I'll put an antenna on this radio and see what... I try to actually tune some stuff this way. Okay, that's another idea. I think this certainly can be included in the bucket of just as this is just crazy nonsense, but crazy stuff leads to the sane stuff. That's what any crazy person will tell you. Okay, so I have an antenna connection. The radio's turned right up. Yeehaw. Put your hand on your volume control. Now I'm going to tune back and forth and see if anything comes out of the radio. Nothing whatsoever. I am on the right coil. Am I on the right band? Let's just be sure. Yes. Get this maxed out. My SDR is very loosely coupled here. Barely coupled in. Okay, I'm going to move the screen over a bit. So I get 11250 on here. This actually worked. Did you hear that? Now, 11465. What happened to my 250 calculation? Could be the radio's way out of alignment. Okay, one of the interesting things about this, that I noticed last night, if you look at the slug tuning shaft for the slug inside this coil, you can see that part of it is dark and part of it is brassy. Hey, it's actually receiving stuff. What happens if I tune the radio a little bit? Don't mess it up here, Jim. Could hunt down a strong radio signal, figure out what frequency it's on using the SDR, try to tune it in with the radio, forcing the local oscillator with my external oscillator. I've kind of already done that. Why would I want to try and do it stronger? Just I was saying that this appears to be tuned out from where it spent most of its life. Tuning that now, how would that help? I don't know, don't think about it, just do it. That's my other guy. Tried this last night thinking, well, maybe this is so far out, the radio can't oscillate. So I turned it in like this, but okay, so that's where it spent most of its life, there. Okay, so 465, we assume it's below. We add 450 to it. It gives you a nice round 11,900 or so. 11,900. How do I know for sure it's because of this, that this radio is operating? Could knock its power way down. And we don't hear anything. Okay, put it back up. So having this coil here is going to detune the circuit somewhat. And paid attention to the SDR. Okay, interesting. Well, what I'm going to do, we can, well, the SDR is sitting right on these frequencies here. I mean, I'm thinking, why don't I try picking this signal up with the SDR and just verify it? Okay, so going back, it would be 11,900. Oh my gosh. What's the story, cat? This is my other cat now. It's complaining. We have bad weather again today, so they can't go outside. But I'm not going to. I'm gonna ignore you. Yeah, I'm ignoring you. I like to talk to my cats. So 11,900. So we look on the SDR for 11,900. It's just off the screen here. 11,900. Is that it? Oops, everything just jumped. A lot. Let's just pull this back here. 11,900. There's nothing there. There's this. Those are not radio signals. What about that? It's not fading in and out or anything. Okay, so I'm going to hook my SDR up to the antenna and find out if we can pick this station up. Just turn the sound off here, turn the sound off here, and leave everything else alone. Pull that out of there. Okay, I'm so spooked here by various noises and stuff. Okay. Antenna's making bad contact again. Oop. Too many wires on the bench. Okay, now SDR. Oh, well, there's a signal. Certainly one here. Let's listen to it. 11,860 is very common. That's 11,930. Okay, so let's do this. What's this guy way out here?
Let's lay it out there. Critical race theory, whether you agree with it or not, it should not be taught in school, and it is still theory. There's no facts behind it. It's theory.
Oh my God. Oh my God. So many people talking about stuff they have no idea what they're talking about. Okay. 11,860. But this one's actually stronger here. So this is either Cuba or Radio Margie we're listening to. 11,930. Okay, so I'm going to dial up 11930 on this radio. 11. Oh my gosh, that's the other end of the band. It may not get there. Okay, let's not use that frequency. We'll use the 8. We'll use this one here. This is, pretty sure that's Cuba 11860. Okay, Cuba 11860. We'll dial this to 11860 here. 11. You know, what am I doing? I don't know. Okay, that's 11860. That should make the local oscillator, if it were operating, run at, and it's below 11860, be not quite that frequency. Okay, see, I didn't want to do adding and subtracting on video. Embarrassing. So we're at 11860. Okay, my pen's running out. 11860. Subtract 455, subtract 460, make it easy. 11400. So this dial to 11400 would be converting 11860 to 455. 11400. Let's turn the radio up. 11400. There it is. Oh, come on. Not very stable here. Tune the radio a little bit. Well, we heard it. Okay, what's this telling me? I don't know if it's telling me much at all. It's telling me if I can present the first detector or the mixer tube with proper local oscillator frequency, the radio will operate. I've got things set so that if there was any way that this coil was just on the verge of breaking into oscillation, you would think this would do it. You would think this would do it. I would think this would do it. I don't know what you would think. Well, I've got an awful lot here to chew on for a while. Think about the implications of this during the rest of my day. Maybe come up with some refinements in what I'm trying to do. But basically, nothing has happened here that suggests to me this set's on the verge of oscillating. Maybe try one more thing. Maybe try one more thing. This is the craziest of them all. So this next idea may not be as crazy as I think. What I want to do is connect a wire with a safety capacitor to the plate of the oscillator tube and then wave the wire, watch out for this end here, Jim, around. The idea is to try to increase the amount of feedback in the oscillator circuit. The reason it's not crazy, and don't forget this radio's on Jim, these wires here are coming from, this is coming from the plate of the oscillator tube. All the signals that are flowing in the plate, I have to look at the schematic to be absolutely sure of this, are being fed through a coil right here. If you look really close, and maybe you can't, there's two sets of wires in this coil. There's the heavy wire, and then there's a very thin wire in between. So on this band, the highest band, 19 meter band, the plate voltage is fed through this coil. Talk about close coupling. What does that tell you? That tells you that's what they had to do to make this thing oscillate on the highest band. So I'm going to try to make that happen on the next band down. This is the one that's operating right now. I'm going to go to the lower end of it. I'm literally going to try to kick it. Kick it. It's a little bit on the dangerous side, so I got to control this. Okay, there's a huge capacitor, unnecessarily huge, but this is what I got. Okay, nobody's dead yet. Nothing happening. What do we expect to happen? The sound in the radio should change dramatically if I can make this happen. You know what? I gotta keep control of this hot end here. Yeah, right. Okay, I'm gonna tune the radio. Means I'm touching the chassis. Everybody safe? Yep. No, come on. This is nutso. But I think it is proof that this radio needs an extra. This was crazy. Let me just undo that. It needs an extra kick. Now, I think this coil is operating all the time. This extra feedback coil, or only operates when you flip in the 19 meter band, or operates for these two bands, because this one's not too far from that coil. Maybe it needs the extra kick too. So is this coil not doing anything? I gotta look at the schematic now. I think that's how we're going to end the video, staring at the schematic. Okay, here's the schematic to stare at. This is that kicker coil right here, L14. You can see that anything that travels on the plate always goes through this coil. They're showing it here as being closely associated with the, did they say which band this is? They did not actually write it on here what band this is, but you know, they're wrapped on each other, so this has to be the 19 meter band. It's got a coil number L, looks like L19 there. So the other bands work, so conceivably this has to be continuous, otherwise the plate would be disconnected and nothing would work and there'd be no plate voltage. Go right down here, it comes right back to that resistor I messed around with. And the other side here is going up to the screen. So exactly how they're making this oscillate, I'm not sure. The grid, could it be that they use the screen in some cases as if it's a grid? And no, this is always engaged. I have a hard time visualizing the effect of the screen in situations like this. The grid, there's that capacitor I changed right there. That's a resistor I changed. And that's the switch. When you're switching onto this is currently shown in the broadcast position. So you can see there's a connection here. So as you snap the switch, I believe what's happening is all these are moving pictorially downwards. The arrow pointing the other way. Yeah, I hate these switches and these radios. Well, okay, like I said before, that's lots and lots of stuff to chew on. And it's a pretty good time to start chewing because it's getting close to lunchtime. Yeah, okay, well, that was an interesting tour through a pile of ideas that none of which really worked, except that last thing. Second last thing, firing in my own local oscillator actually made the radio work a bit. Okay, I'm done. Crazy times. Thanks a lot for watching.